So in this problem, we're asked to write y equals 2x squared plus 4x plus 5 in standard form and use properties of the standard form to graph the equation. So just to recap, remember what that standard form, anytime we have a horizontal shift at least, that standard form is going to be y equals a times x minus h squared plus k, where hk is the vertex. So there's our standard form. So how do we get from y equals 2x squared plus 4x plus 5 to this x minus h form? Not using properties, but using our the properties of the standard form itself, which is y equals a times x minus h squared plus k. Well, again, we're going to complete the square here. So what that means is we're going to factor out whatever common factor we have with the 2x squared and 4x terms coefficients. So we have 2 and 4, which means they share a common factor of 2. So we're going to take that out, and that's going to leave us with 2 times x squared plus 2x. Let's go ahead and leave a space here. And then plus 5. And then we need to complete the square with what is inside the parentheses. So we'll take the 2, divide by 2, and square it. So that equals 1. And remember, we're adding 2. 2 times the 1 makes 2. So we need to subtract 2 from the 5 on the outside. Now that we have completed the square, we have y equals 2 times x plus 1 squared. And then the 5 minus 2 is plus 3. Now we're using the properties of the standard form, of the vertex form. So what does that mean? That means since a equals 2, here's our standard form, y equals 2 times x plus 1 squared plus 3. That's in this form up here. Since a equals 2, that means that the parabola is going to open up. And it's also going to be narrower than if a were just 1. That means our vertex is at hk, which in this case is going to be x minus negative 1. So h is going to be negative 1. And then plus k, so our k is 3. So our vertex is at negative 1, 3. That also means that our axis of symmetry is going to be x equals negative 1. And then since our vertex is at negative 1, 3, which is above the x-axis and it's opening up, we know there are no x-intercepts, but there will be a y-intercept. So we'll go ahead and find the y-intercept and then use the axis of symmetry to find the other point. So let's go ahead and graph the vertex negative 1, 3. And then we'll find the y-intercept. And the y-intercept is when x equals 0. So if we substitute that, let's go ahead and, like I said, find the y-intercept by substituting x equals 0. So y equal, we can substitute it in either equation for that matter, but we'll go ahead and use the standard form that we found. When x equals 0, we have 2 times 0 plus 1 squared, so 2 times 1 plus 3, which is 5. So we have a y-intercept at 0, 5. We'll go ahead and plot that point as well. 0, 1, 2, 3, 4, 5. And then we also know that because of where the axis of symmetry is, that we're also going to have a point on the opposite side of the axis of symmetry at the same point. So negative 2, 5.
We could go ahead and plot a few more points just to be sure, but we'll go ahead and connect the dots. Put arrows on the end to signify the end behavior. And there we have the graph of y equals 2x squared plus 4x plus 5. We converted to standard or vertex form by completing the square. And then use the properties of A, HK for the vertex and the axis of symmetry, and then found the y-intercept in order to complete the graph of the parabola. And we can do this with any quadratic that we're given in general form. It's just a matter of completing the square to get the vertex or standard form, and then using its properties to graph the quadratic, to graph the parabola.